Hi everyone, and welcome back to another one of our instructional build videos. In this build video we're going to go over our electronics bundle kit, and I want to go over details on each element that's going to be included in this kit. It's some awesome stuff, guys, state of the art. Now that you have your mechanical portion of the build done, we're going to be moving on to the electronics, and by the end of this video you guys are going to be running your machine, running code. We're actually going to get to a hello world, so your machine's going to be doing an air cut, which is going to be super awesome to see your machine alive. Alright, so let's go over some of these points now. So here we have our LED light ring, which is excellent for any machine, guys. It's going to light up your workspace completely. It's also an addition that we've added into this bundle, so you guys are going to incorporate this into your build, and no matter what time of day it is, you're going to still be able to work on your awesome projects. Next we have our drag chain, which is perfect for wire management here, guys, and we're using the OpenBuilds modular system in order to assemble it to our X carriage here on the X axis. So as you can see, we're utilizing our single L bracket with additional components to add this nice, sleek, low profile look for our drag chain. Really awesome stuff, guys. So now you don't have to worry about wires hanging around your machine. We've got everything completely configured into our drag chain, and it's going to run into our Y-axis drag chain as well. So as you can see here, we also have our Y-axis drag chain that's incorporated into this kit. So our X-axis drag chain, all your wires are going to run down into your Y-axis drag chain for a super nice low profile look, and it's going to run all the way back to our open case. Our next highlight point is going to be our OpenBuilds open case, which holds multiple controllers. We're utilizing the Xpro in this video in particular, but you can definitely use other controllers if you have one. Also, wire management, of course. All this is running back to one unit and a nice bundled configuration. So as you can see on the OpenBuild symbol here, our fan is operating right now, keeping our controller completely cool. This stuff is awesome, guys. Definitely a nice addition to our kit. And last but not least, guys, we have our micro limit switch kits that are going to be included in this bundle as well. We have configured these into a homing sequence. So as you can see, it's low profile, guys. It comes with all your components necessary to mount this to your C-beam or V-slot. It's versatile, modular, so you can configure them any way that you like. In this build video, we're going to show you how we set up our micro limit switches, which is for a homing cycle. Super convenient for any type of builder, because you already know when you're going to work on different projects, you want to just be able to home your machine by pressing a button, guys. Alright, so now that we've gone over these points, now we're going to go ahead and grab our kit, guys, and let's go ahead and get started. Alright, so on this first step, guys, I want you to locate your wire. So we have 4 conductor wire, 2 conductor wire, and we've also got a power wire that's going to be connecting to our power supply to our Xpro. The Xpro is our controller board that we're going to be using for this. So let's first, what I have here is our 4 conductor wire at 12 feet, and what I'm going to show you is how to strip this wire down. Now it's relatively easy, but for those of you that don't know how to do this, I'm just going to go ahead and show you the tool that I use. Some wire strippers. These are Green Lee. You can get at your local hardware store. They're inexpensive. Definitely a necessity here for stripping down these wires. There are other ways to do it, but I don't suggest doing that because you want to make sure that we have a solid connection to all of our electronical points. Alright, so to get started here, I'm simply grabbing one end of the wire and I'm going to put it in the largest hole spacing here on my wire cutters. I'm going to clamp down, tilt back slightly, and strip that piece off. That should come off easy, and that looks great. So now we have all of our wires exposed, and we're actually going to strip these points as well. Now these are smaller gauged wires, so we're going to have to use the smallest hole spacing here on our wire strippers. So the first one here is what we're going to use. Simply put your wire in, and you're going to tilt back and strip. So you have your wire stripped. We're going to do our additionals the same way. Alright, so that's how you strip your wire down. It's the same process for all of our wire. So make sure you strip down each end of each wire. So all that's left on this wire to do is our opposite end. So we're going to strip that down as well. And this is all preemptive for our assembly process. So we want to make sure that we strip all these wires down. It just really helps, guys. Trust me on this. Definitely going to want to just go ahead and get this out of the way. One other thing I will mention is you want to make sure that you have a decent length on your stripped wires here. So as you can see, I probably have about 5 millimeters. That's about where you guys want it. You don't want it too long, because inevitably these wires will hang out of our connector ports. So you definitely don't want to do that, guys. So make sure you cut them down to about this length. And let's go ahead and get that done, and we'll move on to our next step. Alright guys, so on this next step, we are going to go ahead and assemble our female connectors to our 4-conductor wire. So here I have 12-foot wire times 3, and then our 7-foot wire here, just 1. Okay, and then we have 4 of our female connectors that we're going to be utilizing. And before we do this, guys, if you do have wires hanging off your motor without a male connector, this kit comes with a male connector. You're simply going to assemble it like so. So you want red, green, blue, and yellow. And what I'm going to do is go ahead and show you how this works. Take this off real quick. The reason I have it in that pattern specifically is I have these paired off into coils, and the way that you can tell if your coils are paired correctly, so basically when you touch a pair together, you're going to find resistance in your motor. So by doing this, when I try to move my gantry, you're going to see resistance. It'll actually kind of grind. Okay, so that's red and green. So blue and yellow I'll also test. So you hear that sound? That's resistance in the motor. So we have coil pairs blue and yellow and red and green. So go ahead and snip off the excess here on your motors if you do have excess, and assemble your male pin to these connectors in this order. So left to right, you're going to do red, green, blue, and yellow. So now if you have the motors that have the male pin already connected, these coil pairs are going to differ from the extension leads that you had to strip down. So if you had the old style of motors which had the lead attached to the motor, then you would strip it down and your coil pairs would be red, green, blue, and yellow. But with the new motor style, with the male pins already connected, these are already paired off into coils for your convenience. And those coil pairs are going to be red, blue, green, and yellow. So the way that that's going to correspond to our female connector, if you attach it, you would just correspond the colors of the wires with your 4-conductor wire that you attach to your female connector. So it would go right to left, red, blue, green, and yellow. And you would do that for all of your motors. So make sure that you pay attention if you have the new style of motors, that you connect these in this order. So it would be red, blue, green, and yellow. Alright, so let's continue. And also I will mention, make sure that you have your pins completely loosened. So you'll actually see these metal pins down here at the bottom of the connector, and these need to clamp onto your wire. So make sure as you're tightening, this is rising. So you see as I'm tightening this, my pin is actually rising and it's going to clamp onto my wire. So make sure you guys get that correct, because these usually come standard, which are already tight. So you're going to see this opening here, and your wire is just going to fall right out. So make sure that you loosen this and then put your wire in and then tighten it back down. Alright, so we're going to do that on all of our motors. Make sure when you're doing this you get a solid connection. So twist your wire and make sure it's fully inserted into the male pin. So like so. And then I'm going to go ahead and tighten that down. And what I like to do is I'll give it a nice little tug. Make sure it's not coming loose. That's a perfect connection. Alright, so now I'm going to go ahead and do green next. So remember, follow this order, guys. It's very important. If you're going to follow along with this video, you need to make sure that everything is in line. Alright, so give that a nice tug. Those wires aren't going anywhere. You can see my insulation is fully inserted into the male connector. That's precisely what you guys want. Alright, so go ahead and get that done, and let's go ahead and move on to our extension leads. We're going to take our female connectors, and we're going to line these up to where the wires correspond to each other. So, by connecting this pin, I'll have an identifier. So left to right, I'm going to be inserting yellow, blue, green, and red. So we're going to match that. So just grabbing one of my 12-foot wires here, I'm going to go ahead and twist these wires together, making sure that we get a solid connection in the connector. Okay, so we remember it's right to left. So red would actually be on the complete right side. So I'm going to go ahead and insert red first. Remember to loosen these pins, guys. Alright, so we're going to insert red first, all the way to the right, and then tighten that down. Give it a little tug, make sure that that's not coming out. That's good. Alright, so next would be green. Give that a tug, make sure that it's fully in there. Looks good. Alright, so blue is going to be next. So yellow is last. Alright, now give that a nice tug, make sure all your wires are connected and they're not coming out. That looks excellent, guys. So now we have one of our wires assembled with our female connector. So what I want to do now is go ahead and show you how it connects to the motor. So as you can see here, our wires correspond to each other. So as we make that connection, red matches red, green matches green, blue matches blue, and yellow matches yellow. It's exactly what we want, guys. Make sure you have those in order. And we're going to do the same thing to our additional wires. So in that same order, guys, make sure that you're aligning these wires. And let's go ahead and get that done, and we'll move on to our next step. Alright guys, so moving on to the next step here. Now that we have our female connectors attached to all of our 4 conductor wires, we're going to go ahead and correspond these to our motor wires. So basically what we need to do is make sure that we have the right length wire on the right axis, and we have 3 of our 12-foot wires, 1 of our 7-foot wires. We'll leave this one to the side for now and focus on the 12-foot wires. So let's go ahead and take our female connector here with our first 12-foot wire, and we're going to go ahead and connect that to our x-axis here. So just make sure that you align the pins and go ahead and connect that. Alright, we're just going to leave the wire here for now, so we have our x-axis. Now let's go ahead and move on to the Z, and let's go ahead and connect that. So as you can see, all of our wires correspond to the motor wires. That's excellent, that looks great. So now let's go ahead and move on to our next 12-foot wire here. And this is going to connect to our A-axis. So we're going to go to this side of the machine and plug that one in. Alright, so go ahead and connect it. And what we're going to do with this wire is run it through the square hole here on our Y plate. And that's for the purpose of wire management. So we're going to run that through and leave a little slack here on this end. So let's go ahead and get that done, guys. Alright, perfect. So as you can see here, I've left a little slack, and we'll zip tie this later on our additional steps, but this is what we want. We've got our wire running through the Y plate, and it's left here on the other side. That's perfect. Alright, so lastly we have our 7-foot wire, which is going to go ahead and connect to our Y-axis. So just simply connect those wires, and we're going to leave this one here to the side. Now remember, these ends are left bare for a reason. These are going to connect to our controller board. Alright, so as you can see, we have a bit of a mess here. Don't concern yourself with that. This is going to shape up real quick, guys. Wire management is definitely a messy process sometimes, but we're going to organize this, label our wires, and get everything in order. Alright, so let's go ahead and move on to the next step. Alright guys, so in this next step we are going to go ahead and assemble our micro limit switches. So we're going to require our 2 conductor wire one being at 7 foot and two at 12 feet. We're going to need our micro limit switch kits. Inside the kit you're going to find a drop-in T-nut, slot washer, two of your M3 self-tappers, one of your 8mm M5 screws, micro limit switch plate, and your micro limit switch. So I've got two over here that are assembled. I'm just going to give you an example of how it looks when it's finished. So that's exactly what you should see. Two of these are in a horizontal configuration, and what I mean by that is the micro limit switch is horizontally placed on the micro limit switch plate. So you want to match those two to that same configuration. Now I'm going to go ahead and show you how to assemble this one. This configuration is going to differ. It's going to be for a vertical configuration, and that's going to be for a Z-axis. So first you're going to go ahead and grab your micro limit switch plate, your micro limit switch, and you're simply going to place this on the opposite end of the plate, and you're going to tighten it down with your M3 self-tappers. Now these aren't pre-tapped, so that's why we have the self-tappers included in the kit, and it's going to actually tap our plastic on the micro limit switch. So just going to grab our M3 ball driver here, and let's tighten this down. You want to make sure to keep your micro limit switch as straight as possible as well. So just take your time and make sure you do this right, guys. Alright, and our additional screw here. Same thing, we're just going to tighten that down into the micro limit switch. Just like so. So now our micro limit switch is mounted to the plate. That's perfect. So now we're just going to take our 8mm screw here with our slot washer, making sure that the flat side of the slot washer is facing away from you. That's going to mount to our V slot. And then thread on your drop-in T-nut. Just like so. And that is an assembled micro limit switch. So now we're going to go ahead and move on to our terminal connectors here. So basically what we're going to do is take our wire here, and we're going to run these through our terminal connectors and clamp them down. And these are going to attach to our terminals here on the micro limit switch. So let's go ahead and get that done. You want to make sure that the wire fully inserts into this terminal connector, and then we're going to clamp it down right here towards the end. So I'm going to give you an example here with our positive. So you'll see the wire coming out, and we're just going to go ahead and clamp that down. You really want to put some force on it, make sure that that's clamped completely. And I do it from the top and the bottom. That's how these are designed, so your wire is not going to come out of that. That looks excellent. Alright, so now we're going to do the same thing for our negative. Alright, perfect. So now our terminal connectors are attached to our two conductor wire. So from here, I just want to take notice to our colored wires, so I can still see my black and my red wire. So I want to make sure that you can see those guys, because that's going to indicate our configuration on our micro limit switch. What I mean by that is we're going to have a common, normally open, and normally closed configuration here on the micro limit switch. Since we're going to be using a homing cycle, we're going to use common and normally open. So on our micro limit switch itself, you're going to see these indications here: normally closed, normally open, and our common. So we want to make sure that we have this correct. And this is the horizontally placed micro limit switch. The vertically placed is going to be 12-foot wire. So just put that one to the side. Now this terminal connector is going to connect our positive to our common. So go ahead and slide that into the common. It's going to be a tight little squeeze, but just for a secure connection. And then our normally open is going to be our negative. So we're just going to go ahead and slide that into the terminal. Just like so. Alright, that's perfect. So now our micro limit switch is attached to our two conductor wire. Now we're going to follow the same process here for our additional two conductor wires. So let's go ahead and get that done, guys. Alright, so our next one is complete. So this is one of our 12-foot wires, which we're also going to be using for a horizontal configuration on our micro limit switch. So we're going to go ahead and connect this one. So underneath I can see that this is my red wire. I'm going to connect that to my common. Alright, and then the black wire is going to connect to our normally open, just like so. Alright, that's another one down. So let's go ahead and move on to our additional 12-foot wire. Alright, so now we're basically going to look at the opposite end of the micro-limit switch for this configuration. Based on the way that this has to seat to our micro-limit switch plate, you're not going to see your indicators here for common, normally open, and normally closed. So basically, just follow suit with what I do. The common is going to be here at the top portion, normally open is going to be here towards the bottom. So let's go ahead and hook our positive to the top terminal here, and then our negative to our normally open. Alright, that's perfect. Alright, that looks great, guys. So we have our 12-foot cables attached to the configurations that we need. Our 7-foot wire is attached to the micro-limit switch configuration that this needs. So let's go ahead and move on to placing these micro-limit switches. Alright, so for mounting these micro-limit switches, we're going to go ahead and grab our first 12-foot wire. It's attached to our micro-limit switch that is vertically placed on our micro-limit switch plate. So let's go ahead and grab our M5 ball driver, and let's walk over to the Z-axis. So here on the Z-axis, we can see that there's room here down on the bottom portion, and that's actually where we're going to place our micro-limit switch. So as this comes to a homing position, which would be all the way up, it's going to activate the micro-limit switch, stopping it in this position. So what I'm going to do is just lower this slightly here. I'm doing that with my flexible coupling. I'm going to take my micro-limit switch, I'm going to place it to where my clip is going to activate on this hex nut here. So that being said, I'm going to go ahead and find a good placement, and I'm going to lock in that drop-in T-nut to the track. So now, as we go down, the micro-limit switch is going to activate, and then it's going to stop at the homing cycle. So that's perfect, guys. So we're just going to take this cord and throw it over our X-beam, and we'll worry about that on later steps. So that's perfect. Alright, so one of our micro-limit switches are placed. So let's go ahead and move on to our next micro-limit switch. Alright, so for our next micro-limit switch, we're going to grab our additional 12-foot wire, and this is going to be for our X-axis. So let's go ahead and move over to this side of the X-axis. And from this side, you will see that we have a track available here on our C-beam, and that's exactly where we're going to place our micro-limit switch. So what I'm going to do here is make sure that my pin that's going to be activated is past my belt tensioner and zip tie. That way there's no interference with either one of those applications. And then we're going to do what we did for the Z-axis and tighten down that drop-in T-nut to the track. And then we're going to test this with our X-axis carriage assembly, making sure that it locks into place. So as you can see, we're coming in close here. Move this wire out of the way. And it activates before the wheel hits the zip tie. So that's perfect. Alright, so let's move back to the right side of our machine. Now for this 7-foot cable, we're going to attach this to our Y-axis. And this is going to differ a little bit. Basically, we're going to move our carriage assembly back so we can have access to the front right side of our machine. And we're going to locate this track of the C-beam, and this is where our micro-limit switch is going to be placed. So like we did on the X carriage, we're also going to place this one to where it activates after our zip tie. So let's just go ahead and place this. Alright, make sure that's nice and tight. That's perfect. So my micro-limit switch is past the belt tensioner and zip tie. So before the wheels hit the zip tie, it's going to hit my micro-limit switch. So let's test that. Perfect. Alright, so our micro-limit switches are now placed. We're just going to take our wire and throw it over here to the side for now. And that's perfect, guys. It's coming along nicely. So let's go ahead and move on to the next step. Alright, so moving on to the next step here, guys, we are going to organize these wires. I know we have a jumbled mess right now, but we're going to go ahead and label each wire according to its point of origin. So we're going to label micro limit switches and motor wires. Alright, so let's go ahead and get started here. We're going to start here with our y-axis micro limit switch. So what I'm going to do is take some painter's tape and wrap this around the wire here. I'm just going to go all the way around the wire. Instead of creating a flag, even though it is easier to ride on, it'll rip once we put these through the drag chain. So I want it nice and uniform like so. And then basically I'm going to label this YM for Y micro. So for Y micro limit switch. So just like so. Then I'll put this one to the side. And I'm going to move on to my Y motor. It's the same thing, guys, except for this I'm just going to put Y. And that'll indicate my motor wire. And you can always tell the difference between a micro limit switch and your motor wires, because you're going to have 4 conductor for your motors and 2 conductor for your micro. So I'm just going to put Y, just like so, and we'll put this one to the side as well. And let's go ahead and move on to our X motor wire. So same thing, we're just going to put X to identify that this is a motor wire. Alright, and we're going to put this one to the side. Now let's move on to our Z-axis micro limit switch. Make sure you're tracing these back from the point of origin, guys. I have these like detangled here so I can identify which one is where. So just make sure you're labeling these correctly. Alright, so this one is our Z-axis micro. So I'm going to label it ZM. And put this one to the side. And now we're going to go ahead and move on to our Z-axis motor wire. And we're just going to label this one Z. Alright, put that one to the side. Alright, now we're going to go ahead and move on to our X-axis micro limit switch. So this will be indicated as XM. And lastly, we're going to have our slave axis, which is going to be on the opposite end of our Y. So this is identified as A. And I'll show you later on why it is identified as A once we get to our controller board. But there are labels on the controller board as well, so it really simplifies this process. Alright, so we're going to go ahead and tape this up and identify it as A. Alright, perfect. So just going to go ahead and put that one to the side as well. And what we want to do here is keep some of these wires separated. So basically anything that is located in this area, including our Z-axis and our X carriage, is basically going to stay on this side and it's going to attach to this drag chain. Now on this side we're going to have 2 wires, our Y micro limit switch, which is going to run in this channel here and be covered by a slot cover, and then we also have our Y motor, which is going to run through our Y-axis drag chain along with the additional wires that come out of our X-axis drag chain. So what I'm going to do is just keep these wires down here, keep them separated, that way there's no confusion. And then all of these wires, of course, besides our A-axis motor wire and our X-axis micro limit switch, those are also going to be running in the track of our 20x40 here. But the additionals like the Z-axis micro limit switch, our X motor, and Z motor is going to run directly through the drag chain, which will loop around on a configuration attached to the X carriage. So with that being said, let's go ahead and move on to the next step, guys. Alright guys, moving on to the next step here. On this step we are going to be assembling our LED light ring to our router spindle mount. We're also going to be assembling our X-axis drag chain to our X-axis here. In addition to that, we're going to need our 2 conductor wire at 12 feet for our LED light ring. We're also going to need our M5 20mm screw, one of our single L brackets, two of our M3 T-nuts, one of our M5 T-nuts, one of our 9mm aluminum spacers, one of our M3 6mm screws, and one M3 8mm screw. In addition to that, we're going to have our tooling, our M5, M3 flathead. We're also going to need our permanent marker and painter's tape. And in addition to that, our slot cover, which I've cut down to 995 millimeters. It comes at 1,000 millimeters. So this would be a good place to start, guys. Go ahead and cut that down to 995. In the router spindle mount, I just simply took off of our Z-axis. It's hooked on by our drop and T-nuts. So all you have to do is loosen the screws and take it off. Alright, so to start off, guys, we're going to go ahead and assemble our LED light ring. So just turn your router spindle mount over like so, and we're going to take these black angle corner connectors off. Alright, so once you do that, we're going to take our LED light ring here and we're going to place it on the router spindle mount just like so. Make sure that your holes line up here, because our black angle corner connectors are going to mount on top of this LED light ring. Alright, that looks good. So I'm going to go ahead and put the black angle corner connectors back on. Alright, perfect. So now let's go ahead and mount this back to our Z-axis. So we're just going to work our way around the machine. Alright, so let's go ahead and mount this back to our 2-inch position here. So we've measured from the end plate up to the C-beam at 2 inches on both sides. And this was part of our mechanical portion of the build. So if you haven't marked that, go ahead and measure up 2 inches. And that's where the bottom black angle corner connectors are going to connect. Alright, perfect. Alright, so next we're going to go ahead and attach our 2-conductor wire to our LED light ring. So let's go ahead and bring this wire over with our flathead screwdriver. Now what we're going to do is plug our positive into the right side here, which is for our positive, and then our negative here on the left side. So let's go ahead and loosen these screws first so they can accept the wire. And let's twist these wires, make sure that we get a solid connection here. And let's tighten it down. Alright, give that a pull, make sure that they're in there. That looks great. So now we're just going to go ahead and take this wire and throw it over the right side here. On our other steps, we are going to slide in the slot cover here on the side of our C-beam. So that's going to keep that nice and uniform. Alright guys, so let's move back to the right side of the machine. Alright, so now let's go ahead and label this wire as our LED light ring. So we're just going to grab our painter's tape and do what we did for our other wires. And we're just going to label this one LED. Alright, perfect. So we're just going to put that wire off to the side for now. Now we're going to focus on our drag chain. Now in order to assemble this drag chain properly, we need to make sure that each one of our ends on the drag chain are configured properly. What I mean by that is each one should have a mounting position. This one's going to mount to our 20x40, so it should be faced as it is, like so. And then the other portion of our drag chain is going to mount to our other single L bracket, just like so. Alright, so these are configured properly. If you have any other configuration on your drag chain, make sure you adjust these in pieces. So basically all you have to do is pop it off, like so, and slide it back on in the other direction, and it clips back on. Just another cool thing about this drag chain is it is modular, so you can modify the size as well as these front clips here can pull apart. That way you can lay your wire in. It's really cool actually. It's definitely a nice addition to the OpenBuilds parts store, and it's great for wire management. Alright, so what we're going to do first is take off our Y-axis plate here. All we're going to do is take these two screws out. That way we can free up our 20x40, because we need to slide an M3 T-nut in there. Alright, so all you have to do is slide the 20x40 out. Should come out fairly easy. If you need to lubricate that, all you need to do is spray some silicone in there and it'll slide right out. So go ahead and grab an M3 T-nut and let's slide that into the track of our 20x40, and then we're just going to fix this position back to where it was. And let's go ahead and tighten that back in. Alright, so once we have that tightened back in, we're just going to slide our T-nut down slightly. Alright, from there we're going to go ahead and assemble our single L bracket, making sure that our furthest end from the seam here is going to mount to our drag chain. So this is going to mount to our X carriage plate. So we're going to take our 20mm screw, run it through, add our 9mm aluminum spacer, and we're going to take our M5 T-nut, and we're going to place the T-nut behind this hole here. So we have two in line, which if this were a lead screw driven machine, you would see nut blocks in this spot here. But since we're not using nut blocks, it's a belt driven machine, we're going to utilize this space for our single L bracket mounting. So the top hole here is the one we're going to use. We're simply going to place the T-nut behind this hole, and we're going to thread in our screw. Now it can be difficult to get that T-nut in there. Just be patient and kind of find a way that works best for you. But as soon as this screw will grab that T-nut, it'll lock into place and it's not going to have any movement. So that's a secure mount right there. So now we're going to go ahead and run our wires through our X-axis drag chain. So this top portion here is going to be mounting to the single L bracket. So this is the side that we want the wires to run through. So let's make sure that we get all of our wires together here. The only ones that we're going to leave out are on the opposite end here. We have our X-axis micro limit switch, and we also have our A-axis motor. So we're going to leave those off to the side. Those are going to run into this track and will be covered by a slot cover. Alright, so let's go ahead and get our wires together here. Alright, so you should have 4 wires in total here, and we're going to feed these all through our drag chain. So remember, this is going to be the front portion where these wires are going to feed through. So make sure you have that right, guys. If you want to straighten out the drag chain, which I do, it's a little bit easier to feed these wires through. Alright, so once your wires come through, we're just going to pull them from the opposite end here. Just get all that slack out. Now you don't want to pull it completely tight, because we need a little slack here for our motors to make sure that we still have a solid connection, and we're also going to use zip ties to button up the excess. So don't stress tightening it completely. We're just going to get enough through that it looks nice and uniform. Alright, so that looks pretty good. We have some slack here for additional wires. So we're going to go ahead and mount our drag chain. So bringing the drag chain to the single L bracket here, we're going to run our M3 8mm screw through the center hole here of our drag chain. Just grab your M3 8mm screw. We're going to place it through the hole here of our drag chain. And then we're going to place it on top of the single L bracket. And go ahead and grab your M3 T-nut. And let's tighten that down, guys. Alright, so now we're just going to place our drag chain on top of our cable tray, which is our 20x40 rail. And what we want to do is take our excess wire here and make sure it runs through our square hole here in the Y-axis plate. So let's just find the ends of the wire. We're going to go ahead and run that through. Now be careful when you do this. The edges here on the plate are extremely sharp, so they will strip your wire. So just kind of gradually feed this through, don't force it. Alright, perfect. So another thing that we need to do is we have to get our additional wires here through our cable tray on this track, and we need to cover it with our slot cover. That way all of these wires will go into our Y-axis drag chain. So let's go ahead and move this gantry system down. Alright, so I want to go ahead and take these wires, and what I like to do is get a starting point here on the end with the slot cover. It's going to be a tight fit, guys, so make sure that you put a decent amount of force here on the slot cover. So just get it started like this, and we're going to go ahead and take the excess of wire here and run it through the bottom piece of our drag chain. Right underneath here we're going to run these wires. That way we can mount this back piece of our drag chain. Alright, so we're going to go ahead and run our wires right through this hole, and then we're going to run it through the square hole here on our Y plate. Alright, so once we have that through our drag chain, we're simply going to insert it into the slot of the 20x40, and let's go ahead and finish tightening down our black slot cover to the rail. Alright, perfect. Now that we have our slot cover in place, we're simply going to lock on our drag chain here. So we're just going to push our gantry forward. Let's take our M3 6mm screw, and we're going to run this through, once again, the center hole here on our end piece of the drag chain. And I know there's wires in the way, just kind of separate them in order to gain access. And once you get it in place, you're simply going to lock that onto your T-nut. Alright, perfect. So now our X-axis drag chain is in place. That's looking really sharp, guys. So we have our wires coming out here of our Y-axis plate. So now we're going to go ahead and move on to the next step, guys. Alright guys, so we're moving on to the Y-axis drag chain step. So we're going to assemble our Y-axis drag chain along with some of our single L brackets, our slot covers. We also have M3 8mm screws, our M5 15mm screw, 2 of our single L brackets, 2 of our M3 T-nuts, 1 of our M5 T-nuts, 1 of our end caps, and our slot covers are one being at 1000mm. Our second we're going to cut down to 400mm, and our drag chain comes at 2000mm. What we're going to do is break this down because 2000mm is too long for a 1500mm axis. We're going to take off 27 links. So each one of these connectors is considered a link. So just take off 27 of those and we'll put this to the side and we could use this for another project. Awesome. Alright, so to start this off, guys, we're going to go ahead and take off our end cap here on the right side of our machine for our double end cap for the WorkBee. So let's just take that off real quick. Alright, and these two self-tapping screws we are going to use for our single L bracket. Make sure that the furthest end from the seam is going to be attached to our drag chain. This side is going to attach to our 20 by 40 like so. So let's go ahead and mount that. Alright, perfect. Make sure that that's straight as well. Alright, that's perfect. So now we're going to go ahead and take our end cap with our self-tapping screw and we're going to mount it into the top portion of the 20 by 40. Alright, perfect. So we'll leave that as it is and let's move on to our drag chain. So for the y-axis, we need to make sure that this drag chain is configured properly. Like our x-axis, we're going to make sure that each one of these end caps are in the right direction. So I'm just going to unravel this real quick. Alright, perfect. So the drag chain is going to mount to a single L bracket here on our Y plate from underneath. And then on this side, this is going to mount on top of our single L bracket. So that looks good. Alright, so what we're going to do now is run our wires through our y-axis drag chain. So everything except for our y-axis micro limit switch is going to go through this drag chain, guys. So what I'm going to do is make sure that this is the front end of the drag chain, and then I'm going to insert these wires and run them all the way through. Alright, so now that we have our wires fed through, basically what I like to do is leave a little slack here because we want to make sure that we can mount to our single L bracket underneath. So it's going to be like so. Alright, so what we're going to do now is lay our cable chain on our table. Make sure that we have any additional slack of any wires pulled through. Like I said, we just want to leave a little bit here so we can zip tie this together and we're not pinching our wires into the cable chain. Alright, so from here we're going to go ahead and mount our cable chain to our single L bracket on the back side of the machine, and we are going to mount it with this left hole here on the cable chain. So grab an M3 8mm screw and let's go ahead and run that through this hole and then through our single L bracket, and from underneath we're going to tighten on our M3 T-nut. So if you need to, just go ahead and pull the machine out slightly and let's tighten that down, guys. And what I like to do is I thread on the T-nut first, and then I'll go in and securely tighten it. Alright, perfect. So let's go ahead and take our wires and run them to the back here. And let's go ahead and mount our additional single L bracket here to our y-axis plate. So taking our single L bracket, making sure this spacing here is going to attach to our cable chain, we're going to go ahead and mount this. So I'm just going to run my 15mm screw through with my M5 T-nut, and we're going to mount this on our second hole here on the y-axis plate. So make sure you locate that hole before you tighten this down, guys. And from there we're going to go ahead and tighten this down. Make sure that it's straight before you tighten it down, and then make sure it's nice and secure. Now that's not going anywhere. It's perfect. Alright. So now we're going to go ahead and take our cable chain, and on the left hole here we're going to run a screw through. And then I'm going to take my M3 T-nut and thread this onto our screw here. So like we did our last one, I'm just going to thread this on first. This makes it a little bit easier. And then from there, I'm going to drag this off and tighten it down. Alright, that looks great, guys. So now we're going to go ahead and run our micro limit switch wire through the track of the C-beam, and we're going to cover that up with our slot covers. So we're just going to feed that through the back of the plate here. Make sure to pull all the slack out. And what I like to do with the micro limit switch is I'll run this wire behind the actual plate. It's just like so. And let's go ahead and grab our 1000mm slot cover, and we're going to start it at this point here, and we're just going to place it into the C-beam, and then we're going to slide this all the way down. So once you slide it down, you should see your wire completely covered. That looks excellent. So all I'm going to do is run this wire from underneath, making sure that we still have access to the pin of the micro limit switch. Alright, so let's go ahead and complete this side. Let's go ahead and cover the wire completely. Alright, now that we have our slot cover in place, we're going to go ahead and add our 400mm slot cover that we cut down, and let's go ahead and slide that onto the track. As you can see now, we have our Y-axis drag chain in place. This is looking sharp, guys. This is awesome. Low profile drag chain on both X and Y axis. This looks excellent. Perfect solution for wire management. Alright guys, so let's go ahead and move on to the next step. Alright guys, so on this next step we're going to go ahead and organize our wires using our zip ties. You should see 15 zip ties included in this package. Also our 250mm slot cover. We're just going to cut this in half. And this is going to be used for our Z-axis, so we can secure these wires into the slot. Alright, in addition to that, for our tooling we're just going to need some snips. If you don't have snips, you can use scissors. You can actually use the wire strippers too, they have a cutting end. So that's perfect for any situation. So let's go ahead and start off here, grabbing one of our zip ties. This bundle of wire, I want to make sure that it's nice and secure. So I'm going to tie it into our Y-axis motor wire as well. And I'm going to zip tie these together here from the bottom first, and then we're going to work our way up. Now this is just an example of how you can do wire management and just zip tie these wires together. Whichever way you guys come up with, as long as you're making sure that these wires are secure and they're not going to pull loose, the way that you configure this is completely up to you. I'm just giving you a good example. So now we have the bottom secured, we're going to go up to the top here. And what I like to do with these connectors is I actually zip tie them together too, that way that they're not going to pull loose just in case the machine was moved or jerked around. You don't want to find out that when you turn your machine on, one axis isn't moving. So to prevent that, I'm just going to run this through one side of the connector. Basically I'm running it through the wires themselves to get a secure connection. And then tighten that down. And we'll snip off the excess. Perfect. So now that connector is not coming loose. Alright, so that's definitely looking sharp. Very nice. Alright, so let's go ahead and move on to our Z-axis here. So first I want to make sure that our LED light ring is locked into the track here. So basically you want a little piece of your slot cover. You can use the additional pieces from our additional cut downs of the other slot covers, but I'm just going to cut this one in half once again. That way I have a little sliver in here that's going to secure this wire. Just like so. And that's going to keep it upright and in position so I can zip tie the rest of these wires together. Now we're going to do the same exact thing to the other side. So this will be for our micro limit switch. Alright, so I was able to use the half of the 250 that we cut down, and that looks sharp. Alright, perfect. So now that we have that in place, we're going to go ahead and move to the back side here, and we're going to go ahead and zip tie those wires together. Starting first with our Z-axis connector, I'm going to secure that like we did for our y-axis. Alright, and then we'll snip off the excess here. Alright, so now we're going to go into these wires and we're going to zip tie those together. So right here at the bottom portion, we are just going to go ahead and zip tie that. Just like so. And then snip off that excess. Alright, perfect. So now we're going to go ahead and move around to the left side of our machine to our A-axis. And on this side, we're just going to secure that connector. And let's snip off the excess. Alright, so as you can see, we have several zip ties left. We're just going to carry those over into our following steps. And basically we're going to secure like our power wire and things like that to our Xpro controller. So let's go ahead and carry these over and let's move on to the next step. Alright guys, so moving on to the next step here, we are going to be assembling our case to our Xpro and our 90mm fan. So we're going to need our Xpro, 4 of our M3 hex spacers, 4 of our M3 20mm screws, 4 more of our M3 20mm screws, which will be for our fan. We're also going to need 8 in total of our M3 T-nuts. We're also going to need 4 of our M3 12mm screws, 4 of our precision shims, 2 of our M5 15mm screws, 2 of our slot washers, 2 of our drop-in T-nuts, 2 of our 3mm aluminum spacers, and of course our Xpro case. So taking a look here at our Xpro case, we have 2 identical plates that are going to be stacked on top of each other for a super nice configuration to enclose your Xpro. These plates are awesome. So let's go ahead and start with our first plate here. Taking our Xpro, we're going to go ahead and place it in the center. And as you can see, the Xpro is going to align to 4 of our holes here on our center of the plate. So we want to go ahead and run our M3 12mm screws through each one of these holes. Alright, perfect. So from there, I'm simply going to tilt the plate to the side, and I'm going to add our M3 T-nuts to each screw. Alright, now that we have those added to the back end, our Xpro is not going anywhere, so we're going to go ahead and tighten those down. Now make sure you don't tighten these down too much. You don't want to flex the board, just to where it's nice and secure. Alright, perfect. So this is how I like to mount my Xpro. That way I have access here to my power side of the board. So this is where our power cable will insert. And also we have zip tie mounts here. So we're going to secure that power wire so it's not coming loose at all. So I would match this same configuration that I have here. And let's go ahead and put this to the side. And we'll move on to our next plate, which is going to mount our fan. So for our fan, we're actually going to space it out with our precision shims. So what we're going to do is take our M3 20mm screws and run them into the back end of the plate here. And then from there we're going to go ahead and put on our precision shims. And then let's go ahead and add our fan. Make sure that the sticker is facing up, and that's where the fan direction will be blowing. So we want to make sure that we're cooling our Xpro. Alright, so once the fan is placed, we're going to take our M3 T-nuts and thread them onto each screw. Alright, once those are threaded onto our fan, I'm just going to tighten those down from the opposite end of the plate. Once again, don't over tighten it, guys, just want a nice secure mount. Alright, that's perfect. Alright, so now we're going to go ahead and take our M3 hex nuts and we're going to mount these to each ends of the plate. Now we're just going to do this for this plate in particular, and our hex nuts are going to sit upright because we still have to attach our wires into the Xpro as well as add our power wire. So let's go ahead and get this done. Don't over tighten it, guys, because this is plastic, so it will strip. So you definitely don't want to strip the hex spacers, guys. Alright, perfect. So now our hex spacers are in place. So from here, what I'm going to do is add 2 of my M5 15mm screws to each one of these holes next to our hex spacers. So let's go ahead and place those. And this is to mount to the back end of our machine. So tilting the plate to the side, we are going to go ahead and add our 3mm aluminum spacers, our slot washer, and then we're going to thread on our drop-in T-nut. Alright, and the same for the other side. So just like so. That looks great, so let's go ahead and put this to the side. Alright guys, now that we have those plates configured, we're ready to move on to the next step. Alright guys, so on this next step we are going to be finishing up our assembly for our power supply as well as our Xpro case. So we're going to need 4 of our M3 20mm screws to complete the configuration for our case. We're also going to need our power wire for our power supply, and in addition to that, our 5-foot cable of 2-conductor wire for our power supply to our Xpro. So collect all those items and let's go ahead and get started. So to start off guys, I want to go ahead and get this power supply configured. Alright, so let's go ahead and release the terminals now. So just loosen these slightly. We're going to focus on these 3 sections. So it's a line, neutral, and our ground. Alright, so now that we have those loosened, we're going to go ahead and grab our power supply wire. And this wire is going to be with the plug. So this is what's actually going to give our power supply power. Our additional length of wire we're going to use for Xpro. That's basically to provide power from the power supply to the Xpro. So basically what we're going to do is twist these wires, making sure that they're all uniform. We don't want any stragglers touching the next terminal. I would create an arc, and it's a bad day, guys. So you definitely want to make sure that we get these fully inserted into the terminal, making sure that it clamps down on the insulation. Alright, so starting with our green first, which is going to be our ground, we're going to go ahead and insert that wire into the ground section. Alright, next is going to be the white wire, which is going to be our neutral. Alright, once that's inserted, just tighten it down. Alright, and then last is our black, which is going to go to our line. Alright, and give that a tug, make sure all your wires are inserted properly and tightened down. We don't want any of these coming loose, guys. It could be a fire hazard or it could short out your power supply, so make sure that you have this right. Alright, that looks good. So we're going to go ahead and put our power supply to the side for now. Alright, now we're going to move on to our Xpro controller. So we're going to go ahead and grab one of our labeled wires here, which this one happens to be my Z micro limit switch. So I'm just going to twist these wires, making sure that they're all together. So I'm going to go ahead and locate the Z axis here on my controller. And as you can see, there is a Z here that indicates which section that we're going to be installing these wires to. So the micro limit switch has these 2 connectors here, and that's where we're going to install the micro limit switch. So grab your flathead, and we're going to loosen these 2 end screws here. And we're going to insert red first, so working our way from left to right. Alright, and then we're going to insert black on the right hand side. Alright, and give those a tug. Make sure that they're inserted properly. That looks great. Alright, so we have our Z micro limit switch in place. So now we're just going to go ahead and locate our Z motor. So if you labeled yours like mine, you're just going to see a Z, and that indicates the motor. And obviously we have 4 conductor wire here, so that's going to also be a sign that this is a motor wire. So we're just going to make sure all these wires are twisted and nice and uniform. So right here, if you want to go ahead and pause the video, this is exactly how you're going to wire it with the new style of motors with the male pins attached. So as you can see, the coil pairs do differ, so we need to translate that to our controller board. So the only difference is going to be our A-axis is going to be inverted for the belt drive. Since the motors are mirroring each other, one of these has to be reversed. So the A-axis is the slave, you simply invert the wires. So we're going to have yellow, green, blue, and red for the A-axis. All the rest of the axis are going to be in this order: red, blue, green, and yellow. And that's exactly how you're going to wire it up for the new style of motors. So make sure that you pay attention to this. And I'll also post a link in the description for a diagram of this configuration. Alright, so let's go ahead and move forward. Alright, now for our motor wire, we're going to go in this order starting from left to right. It's going to go red, green, blue, and then yellow. Let's go ahead and start with red first. Make sure all your screws are completely loose. That way we can insert the wires fully. Alright, and then let's work our way to green. Make sure those are nice and tight. That looks good. So now we have blue and then yellow that's going to come next. So one thing I will say about trying to insert your wires into the pin is make sure, I know it can be difficult and tedious at times, just make sure that you're fully inserting it into this slot. So on the Xpro, you see that there's an opening here where our pin clamps down on the wire. Just make sure that it's actually fully inserted into that hole, and that's the only way you're going to get a true connection, guys. So if you were to, stick it into a certain portion of this hole and you weren't able to clamp the wire, it's going to come loose and it's going to cause a short in your board, and at that point it could burn out a driver, it could even burn out the board. So be very careful, guys. I don't want you to burn up your controller, so just make sure that you're twisting your wires completely and you're inserting it into that hole completely. Alright, so once you have the motor wire connected, we're going to go ahead and move on to our next motor wire. Alright, so next we're going to grab our A-axis motor wire. As you can see, I have it labeled here. So on this one in particular, it's going to differ from the rest. All the rest of our motors are going to run red, green, blue, and yellow. For the A-axis, since it is going to be a slave axis, so what that means is the Y-axis motor, whichever direction it's going in, the A-axis is going to follow. So the A is the slave to the Y, and that's just how it's hardwired into the board. So in this particular case, since this is a belt-driven machine, there isn't an application that we can add in the software to invert this. So what we're going to do is invert the wires. Since the motor on the A-axis is turning in a different direction than the Y, it's going to cause conflict. So basically on one axis it's going to be going in one direction, on the other axis it's going to be going in the opposite direction. So we need to cure that by inverting the wires. So in this case in particular, we're going to do yellow, blue, green, and red. So let's go ahead and put those wires in that order. Alright, so once we have those inserted, just make sure that all of them are locked into place. So just go ahead and give them a nice little tug. That looks excellent, guys. Alright, so let's go ahead and locate our other wire. So we'll go to our y-axis. So let's locate that motor wire. Alright, so we have our Y motor wire. So same thing, guys, left to right, red, green, blue, and yellow. So let's go ahead and get that done. Alright, so check to make sure all of these are tight. Alright, that looks good. So now we're going to go ahead and move on to our y-axis micro limit switch. So let's go ahead and locate that. Alright, and YM, so this is our y-axis micro limit switch. So let's go ahead and insert this into the micro limit switch section. So it's going to be red and then black. So let's go ahead and get that done, guys. Alright, so now that we have that inserted, just double check it, make sure that you're fully inserted and clamped. That looks good. So let's go ahead and move on to our x-axis. So taking our x-axis motor wire, we're going to go ahead and insert it the same way we did the others, guys. Alright, so now that we have these inserted, just double check them, make sure they're tight. Alright, and then let's move on to the x-axis micro limit switch. And once again, we're going to work left to right, red, and black. So let's go ahead and get that done, guys. So taking our power wire that's going to supply power from our power supply unit to our Xpro, we're going to connect this first to our Xpro. So right here you'll see a connection here which states positive in our ground. This is where this wire is going to connect. So I'm just going to prep my wires real quick. Go ahead and grab your flathead, and at this point I like to face my case in this direction. So here our power cord will connect, and I want that coming out to the right side. So that being said, we're just going to loosen up these terminals here. Red, of course, is going to our positive, and black will be in our negative, so the ground. Alright, make sure those are nice and tight, guys. Can't stress this enough, you do not want these wires coming loose, because it will cause a short on your board and it'll just be a bad day. So definitely make sure that you have your insulation tucked all the way in here, guys. You don't want any connections between these two sections. That looks good. Give it a nice little tug, make sure those wires aren't coming out. That looks excellent. So now we're going to grab one of our zip ties, and just to make sure this power wire is secure, and if there's any pulling from here, we want to take off that load from the main port here. So what I'm going to do is run a zip tie through this section here, which is designed for our zip ties. And we're going to tighten this down to our power wire. Alright, perfect. And then we're going to snip off the excess here. Alright, perfect. So now when we pull, it's taking the load off of this main connector here. So that looks great, guys. Alright, so now we're going to grab our power supply, and we're going to run this power wire to our power supply. So we're going to prep our wires, and here on our power supply unit we have sections for positive and negative for our outputs. So we're going to align that right here where we see the section split. So it should be 3 and 3, 3 for positive, 3 for negative. So I like to keep my wires in a position to where they don't have to spread from one end to the other. So I'm going to keep these relatively close. Alright, so red's going to be on the left and black is going to be on the right, guys. Put those all the way in to where the insulation is covered and then clamp it down. Alright, perfect. Give that a tug, make sure none of these are coming loose. That looks excellent. Alright, so we're going to put that to the side. And now we're going to go ahead and configure our case. So with our fan on our other half of the case, this is going to be facing in to cool our Xpro controller. So just make sure everything's aligned properly. And from there, we're going to plug in our fan. So right here we have indicators for where the fan is going to plug in, positive and negative. So red obviously being the positive and black the negative. We're going to go ahead and connect that just like so, and that'll make sure that our fan is operational. So with these wires, I know they're all over the place right now, but what I like to do is make sure that they're configured properly to where we have some movement here, and also I want to keep them nice and uniform. So I'm going to run them all out to the left side, and obviously you're going to have some lengths that are longer than others based on where they're positioned on the machine. So at this point it's kind of up to you of how you want to wrap it around the machine, or if you want to bundle it next to the case. It's completely up to you. I'm just going to show you how I do it. So keeping all the wires here. So what I like to do is create a bunch. From there I'm going to place it in between the hex spacers and the controller board, and then I'm going to zip tie that together. And the reason I like to keep the wire with the additional length is just in case I want to configure this a little bit differently. If I want to extend it to the middle of the machine, we're going to be mounting it here on the left side of the machine. That way we have room for our power supply unit to either mount or set to the side of the machine. This gives you options. And that's why I like to keep the length of wire tucked into the actual case. So I have that option. I'm not limiting myself. I've got some additional slack, but it's not a big deal because I'm going to make sure that it still looks aesthetically pleasing, and that looks nice. So we've got all of our wires here to the side, and we're going to zip tie that after we get the case on top. So what I'm going to do is just place the case just like so, and then I'm going to take my additional M3 20mm screws, and we're going to go ahead and lock it into its position. Now don't over tighten these, because these are plastic hex spacers, so they will strip, so just make sure it's nice and tight, but don't over tighten it, guys. Alright, perfect. So we have our case configured properly. All of our wires here are out of the way, zip tied. That looks nice. These additional wires, like I said, we're going to zip tie again, making sure that it's just a nice bundle. Alright, so let's go ahead and mount our case. So like I said, we're going to be using the left side of the machine here from the back, and we're going to go ahead and use these portholes here to access our screws with our drop-in T-nuts on the back end to lock into the track here, which is going to be the bottom track here of our 20x40. So let's go ahead and run our screwdriver through and work one at a time. Alright, perfect. That's looking really sharp, guys. So that's excellent. So we have this mounted to our 20x40 rail. So now let's go ahead and take some of our additional zip ties, and we're just going to button this up here. Make sure all these wires are one unit. Alright, that's perfect. And remember, we still have our LED wire. We're going to connect that to our power supply here in a minute. Just want to go ahead and zip tie this section here as well. Alright, so back here on the power supply, we're going to go ahead and connect our LED light ring. So utilizing our outputs here on the power supply, we are going to plug our red into our positive and then black into the negative. So we're just going to loosen up that terminal, set this up, and tighten it down. And then our negative, and tighten that down. Alright, and also I want to mention on the power supply, we have options here for 230 volts versus 115. If you're in the States, you're going to use the 115. Do not turn this on when it's at the 230 volts. Okay, it's not going to operate. Switch it over to 115 and you'll get power to your power supply, which is then going to control your LED light ring as well as your controller here for the Xpro. Alright, so now that we have our LED light ring in place, we're just going to go ahead and put our power supply to the side, and let's go ahead and move on to the next step. Alright guys, so on this step we are going to go ahead and grab our USB cable. We're going to plug it into our Xpro and then plug it into our laptop. And from here I'm going to go over the software settings, how to download the software, and how to get your machine up and running, guys. So let's go ahead and take the end of our USB cable here. That's going to plug into our Xpro. So right here you're going to see a port, and that's for this this USB cable in particular. So we're just going to plug that in, and then we're going to plug the USB cable into our laptop. Alright, so I've got it plugged in here. So now we're ready to go ahead and go into the software download and the configuration needed for our machine. Okay, so the first thing we're going to do is we're going to go into Google Chrome or any type of internet browser that you have, and we're going to go into OpenBuilds. So just type in openbuilds.com, and up here you're going to see some tabs. We're going to go to the software tab, and we're going to go to the OpenBuilds control machine driver. We do have a CAM option here too. We're not going to get into that too much on this video in particular, but we're going to go into our control machine driver in depth. So make sure you download this control software. Here you're going to see options for Mac, Windows, and Linux. We're going to download the Windows version here because I'm using Windows. So click download Windows driver, and here you're going to see the exe being downloaded. So once that's finished, I'm going to go ahead and open up. So here you're going to see Windows protected your PC. Usually with Windows 10 you're going to see this. Just go to more info and run anyway. Alright, I agree. Next. And then we're going to install. Alright, it's relatively quick, so from there your driver should be downloaded. Yep, and you'll see that the driver started since we do have our USB cable plugged in. So here you're going to have an icon to open up your machine driver. Just go ahead and select that. And voila, here is the OpenBuilds machine driver. This is really nice software, guys. Very easy to use, definitely user friendly. So here immediately I'm going to show you we have COM positions. We're going to go into COM 7. So you're just going to select this arrow here and select the COM that's plugged into your laptop or PC. So go ahead and click the COM 7, and then we're going to go ahead and connect. Now we don't have power to our Xpro controller yet. We have not turned on our power supply, so do not turn on your power supply. We're going to adjust the settings first. So here in the settings tab, we're just going to select that real quick, and you're going to see Gerbil settings pop up here in the top tab. So go ahead and select that, And here where this unlock alarm, it's really just for when the machine is running. It will lock the Xpro so you won't have any movements if it detects that there's an issue with power or any type of code that's not being ran properly. So what we're going to do is take a look at the settings here. So we're going to have values set at standard, which most of these Xpros come with good values actually. We need to adjust all of these based on our machine profile on OpenBuilds. So what I'm going to do here is just kind of pull this to the side. And I'm going to go into the build list here of OpenBuilds. So we're going to go to build list. And go to OpenBuilds machines. And here you're going to see options for all of our OpenBuilds machines. So actuators included. We're working with the WorkBee 1510, so we're going to go ahead and select that. And as we scroll down, you're going to see descriptions of the machine, perks to having this machine in particular with the belt-driven machine, notes. You've got different files showing the footprint of the machine. Really cool stuff, guys, here on the forum. So we're going to go down to our settings tab, which is on down the build page. So right here, you're going to see WorkBee 1510 Gerbil settings. So what's really cool is we've already done the math for you. We've calculated the values based on this machine type and the profile. So all you have to do is copy these settings over into your controller. You're going to save that, and literally that's all you have to do. You're not going to have to adjust those settings ever again. So don't, get freaked out. Oh man, all these different settings. It's really not that complicated. We simplify this process for you. So we're going to click to expand this. And from here, I'm just going to copy these values over. So starting with 0 at the top here, which you might find that some of these are already correct, which is cool. So we're just going to go in and set 10. And we're not going to have to save each time. So with different softwares, you have to save every time you enter in a value. Well, our software is user-friendly, and this has been bypassed. So now we can enter in all of our values for each section and save all at once, which is super awesome. All right, so value 10 here for 0. So then we're going to 1, which that's already set to 255, which is awesome. All right, so step pulse invert is at 0. So none of these are going to be selected. Now step direction invert, we're going to have an option for 3. So here on our tab, it's actually going to show you which axis you're inverting. So with this one in particular, all we're going to have to do is 3, since that's our setting here on the build log. So let's go ahead and select that one. So all it's going to invert is Z. Everything else should be in line. We're going to double check that to make sure. All right, so then we have 4, which is our step enable invert bool. So that one is set at 1 here. So we have options to enable and disable. Since we have the setting at 1, we're going to enable. Invert limit pins, which is 5, is 0, so that's disabled. 6 is 0, so it's disabled. 10, status report options. The presetting here is at 2. We're going to go to 1 is what our direction is on the build log. All right, and 11 is correct. We have 0.020. 12 here for arc tolerance is also 0.002. And each one of these has, specific functions and things that are pertinent to the machine. You can definitely delve into that deeper. There's a lot of information out there on these settings and how they function and how they affect your machine. I'm not going to go into that too much. I just want to show you the basic settings just to get your machine running. I know this is a process, but if you want to delve into that deeper, there's definitely resources online through the forum. You can ask questions. So definitely reach out if you have questions, guys. Okay, so here on 13, this is 0, so it's going to report in inches. It's perfect. 20 here is disabled. It's at 0. 21 is also at 0, so it's disabled. Homing cycle we are going to enable because we do have our micro limit switches set up for homing. Okay, homing direction invert at 23 is 0. We shouldn't. So Z it's a presetting. So basically, since we inverted Z on the homing direction invert, it's also going to set that to 3. So you want to make sure that those match, guys. All right, so at 24, the homing locate feed rate, we have set at 1,000 currently. 24 here shows 100. That's extremely slow. I would recommend setting this to 1,000. You can definitely adjust that later on. That's basically how fast your machine is going to home. 1,000 is actually relatively slow too for a belt-driven machine, so you can adjust that later on if you want your homing cycle to be faster. We're going to leave that at 1,000. So 25, we have homing search seek rate. This is set at 2,500. You can also set that to 1,000, so we're going to match what we did for 24. All right, so 26 is at 250. 27 here is at 3.000. 30 here is at 1,000. 31 is 0. 32, we don't have a laser, so that is definitely disabled. All right, so here we have values for a lead screw driven machine. So steps per millimeter based on the calculation of a lead screw driven machine. Generally, we find 199.100 to be the most accurate for revolutions per step. So with a belt driven machine, this is going to differ. Since this is rotary movement turned into linear movement, we are going to change those values to what it states here at 26.667 for this machine in particular. We do also have an option for the calculator here, so you can actually calculate whichever machine you're running, if it's belt driven, what kind of stepper motors you're using, pulley type, belt type. It's really awesome, very powerful software that we've developed, and it's really easy to use, guys. So you don't have to do those calculations outside of your computer. You can just go ahead and do it here in your control software. Really cool function. All right, so we're going to go ahead and change our value here for 100 to 26.667. Same for 101. All right, and then scrolling down here a little bit more. So 102 is for the Z-axis, which we are running a lead screw. And, even in a belt-driven machine, we're still going to use a lead screw here on the Z-axis. It's definitely, it's for thrust and just a more stable axis for delving into the material. So 102 is going to be set at 199.100. So make sure you guys have that one changed. Okay, here we have X max rate, minimum rate. You can go up to 10,000 with a belt-driven machine. It's completely up to you as fast as you want to run it. So we'll go ahead and adjust those settings. Generally, I don't go to the complete maximum, but for the sake of the video, we're just going to go ahead and do it. So also our Z-axis, since it's lead screw driven, I'm not going to run it as fast as the belt portion of the machine. So the X and Y obviously is belt driven. The Z-axis, I'm going to keep that at 2,500. Okay, you can run it as fast as the settings say. I don't recommend it, so I'm going to leave mine at 2,500, guys. All right, so now we're getting into acceleration. 120 here, we're going to adjust to 150. That looks good. Y-axis at 121 is also 150. That looks good. Our Z-axis acceleration here at 122 is 150 as well. 130, which is our max travel, we're going to adjust that at 824. So that's the maximum travel you're going to get out of your machine here, guys. So as far as the actuator goes, it's as far as it's going to be able to travel. Don't make that larger than what's stated here. We've done the math. We've done the footprint for the machine. These settings are accurate. All right, so y-axis we have 1280. And then our z-axis here at 122. Perfect. All right, so from here we're going to go into save to firmware. Let's go ahead and save that. It's going to give you this pop-up here, just letting you know how these changes are going to affect your Gerbil configuration. So go ahead and click yes. Boom. So now all of our values are set up, which is awesome. You only have to do this once, guys. You can go in here and tweak it once you learn more about these settings and what they do. This is just the base setup here, guys. So what we're going to do now is just go ahead and get out of Google Chrome here, since we have our machine driver operating. And now we're going to go ahead and plug in our machine. So let's go ahead and power on our power supply. And you should hear your machine power on. Your fan should be blowing on your controller, which is very important. You want to keep it cool, guys. All right, so we're going to go ahead and jog the machine around a little bit. So let's go ahead and unlock our alarm here. Go into the control tab, and here you're going to see options for controlling your machine. So this is also a good way to test to see how your machine is operating, if you need to invert something differently. So let's go ahead and take a look at what we got here, guys. Alright guys, so we're jogging the machine around now, and there's a couple things that I've inverted. So going back to our Gerbil settings here, we are going to change our homing direction invert to 3. So in your selection here, you're going to see just the invert Z, and then we're going to go up. And right here in step direction invert, the only directions that we need to invert on this machine in particular is Y and Z. So that value is 6. So we're going to select that, then save the settings. So here you're going to have an option to save to firmware. So go ahead and do that. Then we're going to go back to our control, and we're going to just test to make sure that all of our axes are operating properly. So what I mean by properly too is you need to make sure your positives and your negatives are functioning. So basically, jogging out into the field is going to be a positive movement. Going back is going to be a negative movement. So as you can see, if I press Y here, I'm going to go ahead and move it positive. It should go back. So from where the camera is facing, you'll see my machine go back. All right, and I have my increments set at 100 millimeter movements. If you're testing this, I'd say bring it down to 10 or 1 just to make sure you have everything moving properly. So from the X, we should see a positive movement. So I'm going to bump this up to 10. Facing the camera, it should be to the right of the machine. All right, so we got movements here to the right. That's perfect. Negative, it's going to move back. Same with the Y. It's moving back towards the camera, so that's a negative movement. So here on the Z, it's the same concept. Negative is going to be going down into the material. Positive is going to be up away from the material. So I'm going to set this to 1 because the Z doesn't have as much movement as the X and the Y, obviously. So as you can see, I'm moving negative, and that's going down into the material. That's exactly what we want, guys. All right. So now I'm going to go ahead and hit a homing cycle. So up here, you have home all. Now you need to make sure that your settings are correct before you do this, because your machine might go in the wrong direction. Okay, and at that point, you're going to want to stop the job, stop the movement. So make sure that your homing direction invert is set at 3. Go back to the control, and let's go ahead and home all here. So the Z is going to move first. It found its homing position. The Y just found its homing position. Now the X is going back to its homing position. And once it does, it's going to move back, just like that, and that's perfect. So our homing cycle is working properly. That's excellent, guys.
So that's really convenient for, you know, running machines, especially when you're doing like material cuts, you know, that are extensive. You want to be able to home your machine and not have to worry about it ramming into an axis. So that's awesome. So if you were to home all and you see your machine going in the wrong direction, you're going to hit stop job. Okay, you're just going to press that. So I'm going to show you what that does. So we're going to jog our machine out a little bit here. Go ahead and bump it up to 100 here. So I'm just going to focus on my X and Y mostly. But look at this machine, man. It's running great. This is really exciting, guys. All right, so if I were to hit home all, so I'm just going to bring my Z down. All right, so if I hit home all, and I see this machine is going in the wrong direction, I'm going to hit stop. It's instantaneous, guys. Okay, so with this software, it's very powerful, very accurate and precise. At that point, your alarm comes on too. It sends a signal. It's like, oh, warning, you know, we have an issue. You stop the job. So it's just a precaution. All you have to do is hit unlock alarm. And then we're going to home all once again because we know that our axes are moving in the right direction. That's very important you guys remember that, because I don't want you running your machines off the rails here. You know, if you need to make some adjustments, you can always go ahead and do that. Now I want to show you some other functions here in our machine driver. Check this out, it's super exciting. We've got a 3D viewer. So you can see where your machine's running based on our CAM software. So whatever you upload in your CAM and you're wanting to mill out some stuff, you ran your tool pathing, all your adjustments, you get to watch your machine do its job. So you'll know exactly where it's at. Okay, so no more waiting around, waiting for, you know, a possible signal that's going to show, hey, you know, your machine's halfway done. We're going to actually be able to see it live, which is super cool, guys. We've got simulations down here, reset view, you know, basically the speed of how it's moving. It's awesome. There's also feed rates here. You've got jog feed rate. All of this stuff is just awesome. You can adjust this live. So your feed percentage, you can bump that up while the machine's running to speed up the process. So, you know, obviously that all depends on what materials you're cutting down, what kind of bit you're using. There's a lot of variables to consider before you just jump in and add feed. But it's a cool function. It's there. You've got tool options here, so you can turn on your motor section on the output of the Xpro. You've also got coolant. And this stuff's awesome. We've got a jog widget here. Just super cool stuff. This is constantly being updated too. So if you have questions or concerns about the software, just upload it to GitHub or go on the OpenBuilds forum. And we're constantly on there answering questions or any concerns that you have with the software. But this is basically our machine driver and how it operates. You've got your settings set up. So now your machine's ready to run some code. So let's go ahead and run a hello world. Alright guys, so now we're going to go ahead and run our Hello World code, which we've developed in the OpenBuilds CAM software. So I'm just going to give you a brief look at what that looks like. You're basically going to go to openbuilds.com, go to your software tab, and open up the CAM G-code generator. From there, you're going to see options here to open drawing, machine settings, so you actually can set the machine to its specificity. So 1510 is what we're running. You just select that machine and it's going to upload all the parameters. Very simple, user-friendly. This stuff is awesome, guys. So basically what we do now is we're going to open up our Hello World. We're going to generate our G-code, which is going to be here. And then you're going to simply transfer that G-code to your machine driver. So that's what I've done. Just to give you guys a brief overview. We're not going to go too in-depth with this CAM software on this video in particular, but we'll definitely have a video dedicated to the software in general. Alright, so going back to the machine driver here, you'll see that all your code is uploaded here. So this is your G code. You also have the 3D view like I was showing you earlier. So you can see exactly how your machine's going to be running. So from here, we're going to go ahead and find a 0 point for our machine. Essentially, what we're going to do is move our axis, both X, Y, and Z, to a position that is functional for this G code. So what I've done is I've brought my Z over here. I've brought it down slightly. That way when the machine jumps from the toolpath, raising and lowering, it's not going to grind on the top. So basically, you want to bring your z-axis to about this position here. Your x-axis you want to bring away from the furthest to the left position that it's at. So I've brought that over as well. So as you can see, I'm bringing that over slightly. And also the y I've brought back preemptive, just so we can make sure that the machine is not going to ram into the sides. So from there, you're going to go to set 0 for x, y, and z. So that's going to be our 0 point. Select that, and you'll see that these parameters do zero out. Don't worry if it says 0.01. It's fine. Sometimes it takes the DROs, which are the digital readouts, to upload in real time. So don't concern yourself with that. From there, the exciting part, we're going to go ahead and run this job. So check it out, guys. You're just going to hit run job here. If you have any issues, make sure you hit stop job. It's immediate. But we're going to go ahead and run this. So let's go into the 3D viewer here, and let's watch our machine work, guys. You can see the position of where it's at now. That's super cool. You can also go to the G-code editor, and you can watch it work through the code. But now it's milling out your hello world, guys. This is really awesome. Your machine's alive, it's functioning, it's moving. Just imagine of all the ideas and all the different projects you can do with this thing. This machine's huge. It's got an awesome platform so you can mill out aluminum, hard woods, all kinds of stuff, guys. Super awesome.